in lesson 99 today, we're going to talk about absolute value inequalities, and they're a special kind of conjunction and disjunction that we've already been doing. So if we have something like this and we want to graph it, step one is to get absolute value of whatever isolated, not minus an absolute value. So I have to get that absolute value of x by itself, and there are two ways I can do that. I can subtract the 3 on both sides, so minus the absolute value of x is greater than -3. To make it just absolute value of x, what do I have to do to both sides? Multiply or divide by -1, so this would be absolute value of x. This would be 3. If I multiply or divide by a negative with an inequality, what else do I have to remember to do? Anna? Switch which way the inequality points. Some of you prefer to get there by saying, let's add absolute value of x to both sides. So let's keep the 3 on the right. Let's add the absolute value of x. So we have absolute value of x on the right, and it went away. And then read it backwards. Absolute value of x, smaller signs pointing to that, is less than 3, and we get there the same way. Write it with the absolute value of x on the left. So we want to isolate that on the left side. Just it's going to make it easier as you're thinking about it. When you get to this point, there are two ways of thinking about what that means. First off, in general, what's our definition of absolute value? What do you think? The distance from 0. So I'm delighted that you remembered that. So if we think about that, that is saying right here that we want to graph or shade all x's such that the distance from x to 0 is less than 3. So describe where on the number line I have numbers that are less than 3 away from 0. What are you thinking, Hendricks? And if I had it reals, and you're right because you're remembering or halfway seeing the word integers up there. If it were reals, it would be anything from here to here, right? Thumbs up, thumbs down. If it were reals, that would be the distance less than 3. Because it is integers, we are going to shade only the integers that are between -3 and 3. So solid dots on each of those, and I will get rid of that shading here that is not true for the problem because we do have integers instead of reals up there. Does that make sense to everybody? Okay, now if, that looks kind of like one of those conjunctions to me, doesn't it to you? We were doing conjunctions the other day, right? Yes? Doesn't that look to you guys like we just shaded all of the integers that were less than 3 and greater than -3? Okay, we must, and this is step 2, we need both a graph and we need the algebraic solution using x, not absolute value of x. So my work needed to get me to this, but my final answer needs to have something like this and the graph. So far, so good. Now, there's another way we can think about it once we get to this step in our work. That has a less than symbol, right? And sometimes it's easier to think of that as the less than. And so that means I need an inequality that has and in it. One of them is going to be exactly like what I had here without the absolute value bars. So x less than 3. So exactly exactly as before, just no absolute value bars. The other one is still going to be x. Flip the inequality. And take the opposite of the number that we had. So this says x is less than 3 and x is greater than -3. It also says x is greater than -3 and x is less than 3. Doesn't matter which one comes first, but you've got to have the word and in between. So does that make sense to everybody? Got to end up showing me the steps to get there, the graph, and for this one or the other way of writing that, whichever way makes more sense to you to write it. Okay, that's the slowest one that we're doing. Okay, this one, now we're going to have the domain as all reals. Once again, we need to isolate the absolute value of x. We can either add the absolute value of x to both sides and add 2 to both sides, or I'm just going to subtract 3 on both sides and have minus absolute value of x is less than how much? -5. Have I isolated absolute value of x? No, because I've got the minus in front of it. Alexander, what do I need to do now? Multiply or divide by -1. So I have absolute value of x and I have +5 and turn the inequality sign so it points the other way. This says the distance from x to 0 is more than 5. And this time I am talking about real numbers. So I want to color the things where the distance is more than 5. Baylor, where do I need to go on the number line to be more than 5 away from 0? Well, describe the whole thing. 6 isn't the only one that's more than 5. What would I color on the number line to color everything that's more than 5 from 0? I agree. I agree. 6 is one thing I want to color in, but there are a bunch of other numbers that are more than 5 from 0. So I want an arrow that's going to keep going. What about, is 5 more than 5? What about 5.1? Is that more than 5? And is it a real number? So I need to shade that too. And what about 5.5? And all these, so what do I need to do to show I'm also shading those? What? That kind of looks like I'm including 5 to me. What are you thinking we need to do, Elizabeth? So I need to have an open circle on my 5 to say I'm not actually coloring 5, but I'm coloring all of those fractions and decimals that are just a teeny tiny bit more, and everything 6 and up higher than that. Now, is that everything that's more than 5 away from 0? Evelyn, why are you shaking your head no? I could have gone the other direction as long as I went more than 5, right? So how do I color that on the number line? So thumbs up, thumbs down. Everybody comfortable with that? That's my graph. But I don't have an algebra one written yet that just has an X in it. I can look at my graph and remember when I've done conjunctions before, that was X is less than -5 or X is greater than 5, just from the conjunctions and disjunctions that we graphed before. I could look at the graph and know to write that down. I could also go straight from this with the same rules as before. This was a great or than, so it tells me to use the word or. I am supposed to write one of these just like it is, but drop the absolute value sign. So X is greater than 5. And I'm supposed to write the other one still with an X, but turn the inequality the other way and change the 5 to a -5. And it does not matter if I do X less than -5 or X greater than 5, or if I do X greater than 5 or X less than -5. I can do either piece first, but I do have to have the less than with the -5 and the greater than with the +5. Questions from anybody on that? Okay, then we have 2 quick special cases left to cover. Okay, absolute value is less than -2, domains all real numbers. This says distance from X to 0 less than -2. Distance less than -2. Yeah, exactly, huh? Does that make sense to anybody? Can the distance be less than -2? Distances are always 0 or more, right? So that's nonsense. That's impossible. So my answer there is empty set or no solution, nothing to graph. Makes sense. Okay, what if I had the absolute value is greater than -2? That is saying the distance from X to 0 is more than -2. When's that going to happen? What are you thinking, Charlotte? I don't know. What about absolute value of a half? Does it have to be a whole number? What's the absolute value of -7? And is that greater than -2? Help me out here. What are we thinking is going on? Sabria. Uh-huh. That's always going to be true. No matter what positive or negative number you pick, you're going to get a positive for the absolute value, and that's bigger than -2. If you pick 0, you don't pick a positive or a negative, absolute value of 0 is 0, and 0 is bigger than -2. The distance is either 0 or a positive number. The absolute values are either zeros or positive numbers, and all of those are bigger than -2. So that is always true. So our solution would be all real numbers, and that's an abbreviation that we can use for all real numbers, that double-sided R. Does that make sense to everybody? Because sometimes that'll save you a little bit of writing instead of writing this out like that. While I'm talking about abbreviations, I'll give you a couple more. A double-barred Z is the set of all integers. double bar z with a plus sign is all positive integers. And a double bar z with a minus sign that looks like an exponent is all negative integers. And sometimes that'll just save you a little bit of writing, knowing that you have those abbreviations that you could also use. Anybody know why it's a Z instead of an I or something? What? German? Do you know what German word? Zahlen. Zahlen is the German word for numbers or for counting. So any questions with that? Okay, grab your whiteboards and markers, and I'm going to have you guys do a few of these real fast just to make sure that these are making sense.